Hello everyone, welcome to this session on physical sensors and sensitivity. I am S.V. Goklavarshini, Assistant Professor in the Department of Food Technology at SNS College of Technology. Today we will explore what physical sensors are and why they are so important and how sensitivity and specificity make them reliable in real world application. So let us dive in. So physical sensors are everywhere, from the smartphone in your pocket to the equipment running major factories. In fact, the global physical sensor market was worth nearly 16 billion in 2023. What makes them so important is that they help us translate physical phenomena like heat, pressure, light, or motion into measurable data. They are the backbone of automation, safety, and data-driven decision making. So, what is physical sensor? So, simply put, physical sensors are the device that detects and responds to the physical inputs. Their job is to convert one form of energy into another, a process we can call it as translation. Some common examples you may know include temperature sensor, pressure sensor, motion detectors, and light sensors. Together, they help us control, monitor complex system with precision. So, next is the temperature sensors, the foundation. So temperature sensors are probably the most widely used. So let us look at two key types. So RTDs, so resistant temperature detectors. So these use platinum, usually PT100, and offer a linear response over a wide range from minus 200 degrees Celsius to 850 degrees Celsius. They are highly accurate with a margin of plus or minus 0.1 to plus or minus 0.3 degrees Celsius and extremely stable over time. So next is the thermistors. These are the semiconductor based and very sensitive, and their resistance changes 3 to 5% per degree Celsius, and making them ideal for application where rapid response is needed. For example, in medical thermometers, next is the pressure sensors. So pressure sensors are another cornerstone. So first of all, strain gauge sensors. So they measure the deformation caused by the pressure. So these sensors are highly accurate with 0.05% full of scale and are used in the load cells and process control system. Next is the piezoelectric sensor. So these generates a voltage when subjected to mechanical stress. They are extremely fast, responding in microseconds, and are perfect for detecting rapid pressure changes such as in engine knock detection or medical ultrasound. Next is sensitivity. So now let us talk about sensitivity, one of the most important matrices for the sensor. So sensitivity is simply the smallest change of a sensor that can be detected. For example, if a temperature sensor has a sensitivity of 0.1 degree Celsius, it will reliably detect even a tiny 0.1 degree Celsius changes. So this is crucial for high precision measurement and for detecting early changes such as warning signs in machinery or patient health. So specificity is about accuracy in complex environment. So it is the ability of a sensor to measure just the parameter we want, ignoring everything else. For instance, a temperature sensor should measure temperature, not be affected by humidity or electromagnetic noise. So this ensures reliable data even in multivariable noise environment, something very important in industrial and medical applications. So let's see how this works in real life. In hospitals, sensors continuously monitor patient vitals. High specificity thermistors measure core body temperature to an accuracy of 0.1 degree Celsius, while strain gauge pressure sensor measure blood pressure with a margin of just plus or minus 2 millimeter mercury. So these precise reading helps doctor make life-saving decisions and avoid false alarm. So next is, now think of a chemical reactor in a factory. So RTDs precisely monitor temperature to within plus or minus 5 degrees Celsius, keeping exothermic reactions safe. At the same time, strain gauge pressure sensor ensures the reactor doesn't exceed the safe pressure limit. So together, they prevent accidents, improve yield, and ensure compliance with the safety standards. So physical sensors are evolving rapidly. Miniaturization has led to the MEMS sensors, small, cheap and efficient. Integration with IoT is creating billions of connected devices worldwide. AI and machine learning are now being used to analyze the sensor data, predict failures and enable preventive maintenance. And with the new materials, we are seeing even greater sensitivity and specificity than before. So to wrap up, physical sensors truly are the silent enablers of the modern technologies. They provide precision, safety and efficiency in everything from the healthcare to industry. And as we move forward, innovation in material, AI and IoT will only make them more powerful and intelligent. So thank you for watching. If you found this helpful, don't forget to like and share this video.